Hello and welcome to a new episode of Mixers Inside. I'm Kamilescu and I will guide you through the deepest fragments of the Rane MP2016S mixer. This mixer is a 6-channel rack unit with a very minimalistic signal path. It's equipped with 4 phono line inputs and 2 microphone inputs. You can also plug line level sources via aux inputs and route them to any channel. 2 outputs, effects loop, and that's basically it. You can extend this mixer by adding XP2016S processor. The circuitry is placed on 3 boards. The PCBs are really big and are definitely not crowded. Rane Company deserves praise for providing schematics of their devices. This way they are extending their product longevity and provide users the ability to operate the equipment for decades or even centuries. And finally, they provide me the ability to do a really deep dive now. So let's start from the beginning and examine the inputs. First, based on what we see, I will tell you how to read the symbols on electrical schematics. Every physical part is visible on the schematic. First basic part is resistor. It limits the current. The resistor shown sets the input impedance. Capacitor, the second basic part, stores the charge. Here it's a part of high frequency filter. The switch activates 30 dB attenuator. This mixer is IC-based and uses operational amplifiers. Op-amps are high-gain amplifiers with differential inputs and have a very wide range of applications. Potentiometer is simply an adjustable resistor. Thanks to this we can set the gain of amplifier. Next we have electrolytic capacitor, here it's used for DC blocking, and a film capacitor setting the time constant of the EQ filter. Resistor, capacitor, operational amplifier. Understanding those elements means understanding this mixer. Most circuitry here is based on various combinations of those 3 elements. Microphone amplifier consists of 2 stages, input stage and 2 bandback Zandal EQ. Now let's take a look at phono line inputs. There are 4 phono line inputs here. Phono and line stages share a common connector. Phono preamp is a well-known single-stage active solution. I can finally show you what does it mean. Phono amplification is done by a single non-inverting amplifier that uses a RIA equalizer in the feedback loop. That's why it's called active. By changing the switch position you set the gain to unity and transform phono preamp to a buffer. Microphone and phono line inputs are placed on input select board. On this board we can also find input selector switches that allow us to choose between the main inputs and aux inputs. This module later. Let's get back to block diagram and see where the input signals go. They go to the input gain and monitoring section. This section is placed on the smallest of 3 boards and is very simple and straightforward. The gain module is based on 33078 op-amp. I think that the secret of this mixer's sound mainly lays in those chips. Gain circuit is just a passive attenuator followed by a voltage amplifier. Thanks to this we can attenuate and amplify the signal. Monitoring section uses op-amp as a comparator and glows the LED when a certain voltage level is exceeded. On this board we can also find some switches to control some things. After setting the gain, the signal flows to the main channel volume control circuit. This circuit is also very basic and simple. The signal flows to the potentiometer and is then buffered to keep the output impedance constant. Then signal from every channel is sent to the most essential part of the mixer, summing amp. It's also based on 33078 op-amp and uses virtual ground configuration. There's also an alternative path for signals from channel volume circuits. They are also hooked to the connector that allows to send them to external processor. So as I said, there are 2 paths for signals going from individual channels. They are summed directly in the mixer or sent to processor and summed in the processor. The switch allows us to choose from which summing amp we want the signal to be further processed. Straight after the switch, the signal goes to the subsonic filter. Not every mixer has it, but it's a very useful thing in the club environment. It cuts off unnecessary low end that may cause feedback. So we have all the sources summed. What else can this mixer provide? It has an Isolator EQ control on the sum. The Isolator EQ is based on active filters that chop the audio signal to 3 bands and then sums them again. I've already made a video that contains detailed explanation of this topic. As you can see, the capacitors in the filters are film type, but it's hard to determine what kind of film they use. We are almost coming to the very end of Rane signal path. Signal from the master isolator is split to house and booth outputs. Each of the outputs have dedicated volume control placed on the input select board. Signal that goes to house output can be sent to outer world in two forms: balanced or unbalanced. When sending the signal with long cables, it's always better to use balanced connection. But to convert the signal to the balanced form, we need a special driver. Balanced driver doubles the signal and inverts the phase of one of them. As a homework, you can check why. We know everything about the signal that goes to the main speakers, but we didn't discuss the Q monitoring section. In order to monitor the signal before mixing it, the individual signals are stolen from the point before the channel volume control. Then, they are sent to the Q switches that route them to the Q summing amp. I've spotted one design flaw here. The unconnected signals should be tied to ground, otherwise the summing resistor floats and picks up the noise that is also summed with other signals. Signal from the Q summing amp goes to the headphone amp section. Here you can see how the Q summing amp looks on the board. There's a potentiometer that works like a crossfader and allows you to blend Q and master signals. The blended signal is sent to the headphone amplifier. Every channel uses both amplifiers of 33078 chip. We have one more very important thing to watch, and it's not visible on the block diagram. The power supply. Just like in most mixers, the power supply is switch mode, and I must emphasize that there is absolutely nothing wrong with that. The superiority of linear power supplies is a myth, unless someone designs the switch mode power supply in a poor way. This power supply is an isolated flyback converter, and I briefly described this concept in the Xone 92 video. You'll find a lot of detailed information in the web about how does this thing work. Now let's measure the THD like we always do. When the meter diode starts to glow green, we get minus 100 dB of THD. Let's crank up the gain a bit. Even though the LED is still green, at higher positions of the mixer's gain potentiometer, the signal starts to seriously distort. Now let's push the level till the LED glows red. Total clipping. Red means really red here. So, if you watched my Omnitronic video and for some reason you remember the measurement results, you will easily notice that THD figures of Rane and Omnitronic are almost identical. Does that mean these two mixers have a similar sonic character? Of course not. That would imply that the selection of different op-amps doesn't matter at all. So far, we've been measuring THD for a single frequency, and based on that number alone, we are able to notice significant differences between mixers. If THD measured at a frequency of 1 kHz shows the same results for both mixers, we need to examine the matter more closely. Let's measure the THD for all frequencies in the audio band and see how it's changing. This way, we'll see how the mixer distorts for each frequency. This graph illustrates the capabilities of my measurement equipment. As you can see, it's not outstanding, so the measurements taken will only provide the approximate results, but we will still learn something from them. The good thing is that apart from the high frequency bump, the THD versus frequency remains flat across all audio band. Compared to the loopback measurement, we can notice a significant difference in low frequencies in Rane mixer. They are much more saturated. Medium and high frequencies in Rane have pretty much flat THD versus frequency. The high frequency bump of the measurement device can affect the measurement, so it's just an approximation. THD versus frequency graph of Omnitronic looks totally different and opposite. The low frequencies have low distortion, and signal is distorting more in the high frequency region. It may justify widely spread opinion about Omnitronic sound character. For sure, it's not warm and fat, and the high frequencies can be perceived as harsh. I hope that your brain is not boiling from the amount of information provided. Please remember that you can always pause and rewind the video, use Google and read books to have the full image. Never ever blindly trust opinions on the internet forums. To sum things up, I think that Rane MP2016S is a great example of good sounding mixer that has a very simple and basic signal path. No esoteric stuff here, just clever selection of op-amps. The quality of mechanical parts is decent, passive parts are just medium quality, no super expensive audiophile stuff here. Is it worth its price? I'm not that wealthy, so I'm not voicing my opinion. Thank you for 1000 subs and see you next time!